So before I start my talk, I want to talk about a dilemma that most developers face. So when you work on a bug fix or a small feature, it's all good and fine. You check out your code, you work on it. After a couple hours, you're done, and you check your code back into the revision control system. And that works out well. However, if the task is a little bit bigger, if you have to work on a big feature, it might take a few days, maybe a week, maybe a few weeks in order to complete the task. So during this time, you face a dilemma. Do you want to check in your code and potentially break the build? Maybe your code is not debugged properly, or you don't have all the tests written yet. And maybe you even forgot to include a dependency and you break your colleagues' development environment as well. And drive everyone crazy by checking in your code. The alternative, of course, is to not check in your code as well and potentially go without version control for days or even weeks. And of course, that's not a good alternative. My name is Jens. I'm the product manager of Bamboo at Atlassian. And today I'm going to talk to you about DVCS, explain to you what DVCS is and how DVCS can change the workflow and can change the way you work. So let's start with the overview. First of all, I'm going to talk about Mercurial versus Subversion. What are the advantages of Mercurial and what are the advantages of Subversion? Next, I'm going to talk about basic concepts, the architecture of distributed version control systems. And number 3 is use cases. I'm going to talk to you how you can use Mercurial and other distributed version control systems in your daily workflow and to work with your team. So in the following presentation, I'm sometimes going to refer to Mercurial as HG, which is the element in the periodic table. So this is what all the commands are using. But first of all, welcome to the Fight Club. This is Mercurial versus Subversion. And unlike in the movie, I encourage you to not follow rule number 1 or rule number 2, and do talk about what you learned in the Fight Club today. Our contenders on the, is that right? That's the right-hand side this time. On the right-hand side, it's, no, left to you, sorry. On the left-hand side, Subversion in slightly green, and on the right-hand side, Mercurial. And they're going to fight it out over a few rounds on a few topics that I'm going to mention. And we're going to start with merging. Who likes merging in Subversion? Oh, one person there. Very nice. So it's already not looking too good in Subversion. So the reason why you don't like merging in Subversion is because if you work on a branch and you commit your changes and keep working on it for a week, and eventually you want to merge back with your team, it's going to take your revision and tries to smash all of that stuff that you have in your one revision at the top of your branch with the top of the trunk and tries to smash it all together. That generally ends up being a really bad, unholy mess, and you get pages of merge conflicts that you have to often resolve manually. In Mercurial, however, Mercurial was pretty busy while we were changing stuff on our branch and while the other people were changing stuff on the main branch. Mercurial kept track of all the changes that we performed all along the way, and when we finally decide to come together again, it will apply all those changes recursively. So it keeps actually track of what we do on the way, and it knows that, unlike Subversion, which tries to just mash together two states. So this is why merging is better. And it's important that it's better because we want to branch a lot in Mercurial. Because distributed version control systems are all about having repositories in very different locations, and you branch very often. It's probably part of your daily workflow to branch. And this is why the Mercurial developers decided to make it really easy. It's similar to when you release software. When you release software once a year, it probably takes you 3 days or a week to release your software, and it's really, really painful. However, if you release the software every week or every day, then you can't afford that it takes 3 days in order to release the software, otherwise you never get done. And you want to make it as easy as possible. And this is similar what the Mercurial guys did with Subversion. And the Mercurial guys did with merging and branching. And Subversion, the people are just used to merging being a pain. The next one is repository access, and Mercurial is going to win here again. Because in Subversion, every time you want to interact with the repository, you have to go over a wireless connection. You have to go over the internet in order to access the repository. Every interaction with the repository goes over the internet and has a latency. If I want to commit something, it goes over the internet. If I want to check out something, it goes over the internet. If I want to look at the history of a file, it goes over the internet again. In Mercurial, however, every developer has their own repository local. So every interaction with the repository is on my local machine, and it just takes a fraction of the time because I don't have this network delay to deal with. So if I want to blame someone for a change I saw, it just takes a millisecond, right? It doesn't take a second because I have to go to the US, download the changes from the server, and come back to Australia where I'm located. Right? So the repository access is much faster in Mercurial. So next we go, well, that was the performance. Another advantage, of course, that I forgot to mention before is that when you're on a train and you don't have internet connection, then again, you can work with your repository. You can commit changes to your local repository and you don't have to deal with it. So you don't need online access and the performance is much faster. Sharing your changes, and we already talked about Subversion, and when you commit your changes, there's only one central repository that you commit your changes to. So basically, you don't have another choice but sharing your changes with every other developer and also your build system that also accesses the central repository. In Mercurial, however, because there's so many distributed version control systems and repositories everywhere, every developer has their own, you can change and choose, who to exchange your code with. You can just push your changes either to Don, if I work with Don on a feature, or if I work with Jonathan on a feature, I can just push my changes to Don's repository, or he can pull my changes over into his. I don't have to share it with the whole team. I don't have to share it with the team that works on a completely different feature. However, Subversion does have a few advantages. I'm going to take a few punches here. The tool support is still much better for Subversion at this stage. Subversion has been around for a long time, and a lot of developers know Subversion, and therefore the tool support is really good. The Atlassian tool support for Subversion has been around for years, and the same is true for the IDE as well. However, with the next version of Fisher and Crucible, as well with Bamboo, we're going to support Mercurial out of the box as well. And hopefully the IDEs are catching up soon too. Another thing in Mercurial is authentication. So in Subversion, again, since you authenticate every interaction against the central repository, Subversion always knows who you are. You always have to provide your credentials to Subversion in order to do anything. In Mercurial, because your repository is located on your own computer locally, you actually can define in a text file whoever you are. Like you can say I'm Donald Duck and you can commit your changes as Donald Duck and nobody actually asks you for any credentials. Nobody doubts that you're Donald Duck because you're on your own machine. However, if you have a central repository, and this is how most people work, I will show you that soon, you have to eventually provide some credentials in order to push your changes along. But all the changes that you committed on the in between are marked against Donald Duck. So it's a little bit hard to track who actually committed the changes for a specific change set, and you can be Donald Duck if you want to. Most developers don't find that to be a problem. Like a lot of open source projects, they deal with this daily, and I haven't heard of anyone having a problem with this, but I can see how some organizations might be concerned with that. And the last one is checkout. In Subversion, you can simply go and check out a tag or a specific revision, parts of the repository. In Mercurial, you have to check out the whole repository at all times, otherwise you don't have access to the history. So if you have a large repository, maybe you have a lot of binary files checked in, like the Fisher guys do with 2 gigabytes of repository, then you have to check that out once into your local repository, and that takes a while, and it's a little bit painful. However, you shouldn't have binary files in your repository in the first place. Okay, so in the end, I still think Mercurial wins this fight. And it's because the way it handles branching and merging is really important for a developer's workflow. And why it's important, I'll show you at the end of this presentation and how it makes things easier. But for now, just trust me, Mercurial is definitely the winner here. All right, let's look at the basic concepts after I had a drink. So the repository architecture for Subversion is somehow like this. You have this one central repository in the middle. Again, everybody accesses it. In this case, Bob and Alice they are or Alice, is it Alice in America? Or Alice, they both work against this one central repository. Whenever they change something and commit the changes back, they commit it to the central repository and share it with each other and the rest of the team. And probably your Bamboo server as well. So your Bamboo server is connected to the central repository, and every time somebody commits it, it picks up the changes from the repository, starts a remote agent, possibly an Amazon cloud, and then runs the build and checks whether all the tests run correctly. The problem is, what if you want to commit something and you don't want Bamboo to pick that up? Then it all of a sudden gets a little bit tricky, and you might break something. So developers usually try to test the changes first locally because they want to avoid to break the build and annoy everyone else with their changes. In DVCS and Mercurial in particular, the setup is a little bit different. So every developer, as I mentioned before, has his own repository. So you have a repository locally, and you can commit and interact with the repository on your own machine. And then, for example, the Bamboo build server can have his own repository as well. So if you want to share changes that you make with Alice, you can do that. You can just push and pull your changes from your repository into Alice's repository and work together with Alice. And if you feel that your changes, after you merge with Alice's changes, are all complete, then you can send them to the build repository. And Bamboo builds from the build repository. However, if you have a lot of developers, I think the Jira team and Confluence team have 20 developers, there are going to be a lot of repositories around, and it's going to be hard to figure out who actually has the latest version of the code and who worked on what. So how a typical development team sets it up, they use a master repository or an official repository. So whenever you are done with your changes and you confirm that everything worked, you might commit it to the master repository. An alternative here would be that you push your changes to the custom build repository. It runs a build, and only if all the tests run correctly and run green, then Bamboo could push the changes to the master repository, to the official repository, in which case you would always have your working code in the official repository. And this would also be the repository from which you do your releases, your tags. So another thing to point out is that Subversion is always linear. In Subversion, when you commit something, the first commit is revision 1. If you do a second commit, it's revision 2. So it's always linear, always n+1. And in order to do that, of course, it's simple, but you need the central repository that keeps track of the numbering. In Mercurial, one revision, or in Mercurial they're called change sets, can actually have multiple children. You can't really see that here because I just worked by myself so far, but I did 3 changes to my code, and you see this is what it looks like here. I've got a change set 1 to 3, and the latest change set here is called the head. So let's say I share my first change with Don, because I've been working on a feature with Don, and I share my first change with him. And he goes off and commits 2 more changes to the repository, to his local repository. So those 2 repositories are completely separate. One is on Don's machine and one is on my machine. So eventually, after we both finished our feature work, I finished my features, Don finished his features, we want to bring our changes together. So we either can push the changes. I can push my changes to Don, but that wouldn't be so polite to let Don do the work. I decided to pull his changes into my repository. In order to do that, I just pull and reference his repository, and now the changes are part of my repository. They're part of my repository history. However, after pulling them, they don't appear in my working directory. I can't see the changes yet. In order to see the changes, I have to merge first. And again, the merge is simpler because what Mercurial is going to do, it's going to look at my change sets, the blue ones, C3 and C2, and it knows that we both started at C1. So it looks at the differences from Don as well at the yellow change sets, and it merges them all together. So this is much less likely to create a conflict than it would in Subversion, where it only compares the latest state of the repository. So again, let's review a few of the commands that we used. We used hgcommit in order to create a new node in our repository. We used hgpush and hgpull in order to push or pull changes from one repository to another one. And we used hgmerge in order to merge the changes within one repository together and have them visible in the working directory. So one thing that people often get confused about is branching in Mercurial. And even, I think until last week, I was a little bit confused about branching in Mercurial. Because there's so many different ways to do it. In Subversion, you have one way to branch, and that's the way you do it, and that's the way it's very painful, right? So we've already figured out nobody likes it. In Mercurial, you have various ways. And I'm going to explain all those different ways of branching to you and when you would use what type of branching. So let's start with forks. A fork is basically a clone of a repository. In this case, we decided we have already 2 change sets, and at the change set number 2, we decided to clone the fork, to fork the repository into a separate repository. We simply do that by calling hgclone, the name of the project we're currently working on, and then the test project for the branch. So the advantage now is that we have 2 completely isolated repositories. They don't share any history. They're completely separate on your hard drive, and you can just CD into one repository, start working on it, commit changes, and the other repository will not know about it at all. So the advantage, it's complete isolation. You can just do stuff, and nobody else will know about it. And what's good about this is if you want to get rid of the changes, if you want to get rid of the branch because something didn't work out and you don't want to actually have the changes in your history, you can just delete that directory and discard completely the branch. Unfortunately, the repository, and well, actually, I should mention that this is the most common way people work on Bitbucket right now for open source projects where they don't have commit accesses. The problem is that forking is a little slower than the other types of branching. The reason is that we start off with one repository, and we probably already have 10,000 change sets in that repository. Then we fork this repository and create another one. It's basically an identical copy of the repository we already had. So now we have 2 repositories. So if you do changes on both repositories now, we still have the 10,000 lines, 10,000 change sets in one and 10,000 in the other one, plus the changes we put on top of it. So that's all fine and good if you work locally. The copying and the cloning is very fast. However, if you work with another team and now you have to share the repository over the internet with like someone else, now you have to share 2 repositories and twice the code. So that would be 20,000 change sets now you have to share, plus whatever you added on top of it. So it's not just the first repository that you have to share both. So they have to download all that data. And therefore, you shouldn't use forks if you work on a team that already has access to the repository and commit access. If on an open source project, like on Bitbucket, if you're interested in one of the projects and you don't have commit access, it's easy to clone the project, do some changes, and then ask the author to pull back your changes into the main repository. And he can verify the changes that they're good and that they like it. So it's a great way to interact with an open source community. But for a team within a company, it's probably not the best way to create branches. Or if you want to experiment on something. On Atlassian, we have FedEx days. I'm sure you heard about those. And those are a great example on how to use forks. So you just clone a repository locally, you work on it for a day, and maybe something comes out of it. And if not, you're just going to discard of the changes. You don't need to merge them into the main repository of Confluence or Jira and keep all the history around. And the last example is the build repository, of course. I mentioned that before. You can have a separate build repository that the build server is connected to. So whenever you push a change to the build repository, the build server kicks it up, runs all the builds, and maybe pushes it to the official repository afterwards. The second way of branching is actually called branching. So that seems to indicate that it's a good way to do it, I guess. They call it named branches. And in this case, again, we had 3 change sets, and at change set number 2, we decided to branch off to a new feature branch and just have the default branch as our bug fix branch. In order to do that, you simply call hgbranch and the name of the branch you want to call it, and it will automatically create a branch within the same repository. So now when somebody else if you need to share that repository with someone else, they just need to download one repository. You can see the little markers at the top. They're actually dashed, which indicates that there are no actual objects. Those tags don't actually exist as objects anywhere. They're merely convenient names that allow you to jump between branches within Mercurial. So if you want to update your working directory and work on a branch, you simply call update feature, and it updates you to the feature branch, and you can start committing on a branch. So the advantages are that, one thing I missed to show you actually. So you can see the normal change set have the number of the change set and a summary there, so fix something. But for the yellow change set there, you can see that there's a summary as well as some metadata for the branch. So it actually keeps a record of which branch this change set was created on, and it will keep that around forever. Which I think is an advantage because you always keep the context on when this change set was created and in what context. And the whole thing is faster than forking. We already established that. Some people don't think it's a good idea to keep that metadata around forever, even though it's just small and you won't even see it, but they consider it a disadvantage, especially when they come from Git. And why that is, I'm going to show you soon. And up until Mercurial 1.2, you were actually not able to close a branch, which convoluted the branch namespace. You just accumulated branches endlessly. But now you can close a branch and it won't be listed anymore when you list all the branches available. So again, when would you use named branches? If you work on a team of which all members have access to commit to the repository, to the main repository, then you should use named branches. It's a better way of working because you don't have to download as many changes. And you keep track of the context in which the changes were created. So I think it's a good feature. The next one are bookmarks. And bookmarks are very similar to named branches. And I think the main reason why bookmarks were invented are probably because this is how Git does it, and it's the closest to Git, which is a competitor or an alternative to Mercurial. So the way you create a bookmark is similar to branches. You just call HG bookmark and then the name of it. In this case, we create a feature bookmark, and you can see at changeset 2, we created 2 bookmarks. We created one for the main branch, and we created one for the feature branch. So unlike before, where we had the dash tags for the default there, you can actually see they're not dashed anymore, those tags for main and feature. This is because bookmarks actually live as an object in the repository. They're an actual object that you can interact with and delete with later on. So again, if you want to discard a branch or a bookmark, then you can just delete the bookmark. So bookmarks are quite lightweight because you don't have to do much. You create it and you can delete it as well. And it's very similar to the way Git does branching. So if you're already familiar with Git, you probably like bookmarks. However, until Mercurial 1.6, bookmarks were only local, which means you couldn't actually exchange them with other repositories. You were not able to pull or push them into other repositories, which is probably the biggest disadvantage. And there are like a few little problems with bookmarks as well, so I would encourage you to read up on them before you use bookmarks. There's also possible loss of context because I mentioned there are objects that can be deleted, so you can simply delete a bookmark and the change set won't have any knowledge about in which context it was created. So you lose that context. When would you use bookmarks? Similar to branches, you would use bookmarks if you work with a team within a company, I guess, if everybody has access. And of course, if you like Git, then it's probably a better and more familiar way of branching. And you should make sure that you use Mercurial 1.6 if you want to use bookmarks. And the last and probably cheapest way of branching is anonymous branches. And the way you do that is you simply update to a specific revision, your source repository. You simply update the working directory to a specific change set, in this case, change set number 2, and start committing from there. Because Mercurial has a branch structure, it will just branch out and create a new branch of change sets. And you don't have to think about any smart branch names, and you don't have to remember to close it afterwards. You can just commit to that branch, and if you're done there, you merge the changes back. So typically, you would use this when you have small changes, right? Because there's no description here. There's no description of when this happened or why it happened. You can see it in the graph, but you don't know what type of branch it was. And it's a little bit painful to jump between those change sets because you actually have to look up the change set number of the branch in order to jump to it. You don't have this convenient naming that we have with bookmarks or with branches, or we can just go to the repository like with forks. So again, if you don't want to worry about closing a branch or naming it. If you don't have a good name and you just have a small bug fix that you want to perform, then you can just branch off with an anonymous branch real quick, fix the bug, and merge the changes back. So I hope that provided a good overview of branching, and now you have an idea of when to use which branches. So in the following use cases, I'm going to talk a little bit more about the branches and how to use them actually, and to what advantages. But before I start talking about this, I would like to talk about Bitbucket. So I mentioned before that you typically want to work against a main repository, an official repository, and for those use cases that I'm going to present now, I used Bitbucket as an example on how to do that. So Bitbucket, for those of you who don't know, is a Mercurial code hosting repository, code hosting service that has been acquired by Atlassian recently. We now offer free accounts for 5 users, and if you have an open source project, then you get unlimited public collaborators, so unlimited numbers of users or can contribute to your project. And you get unlimited disk space as well. But don't put your iTunes library up there. Thanks. That would be good. And if you create your repository on Bitbucket, the first time you access Bitbucket, it looks like this. It gives you a small little quick start guide, some examples on how you clone it to your local repository and how to interact with it, how to push changes back, and how to import maybe existing code you already have. Before I move to the examples, I just want to make you familiar with a few of the commands I'm going to use. hginit. I'm not going to use it, but I'm just going to let you know. If you don't create a repository on Bitbucket, you can use hginit to create a local repository for yourself. You can use hgcommit in order to commit new changes and create a new node in the repository. hglog in order to view the changes that you made to a repository. You can use hgpull and hgpush to exchange changes between 2 repositories. And you can use hgmerge in order to merge them in one working directory. And at the end, hgupdate allows you to jump between different branches within a repository and to update the working directory to a certain revision if you need to start working on it. So let's say I want to work on several features. I have to fix this bug, but I'm also on the feature team, and I have to work on another feature. So locally, I probably would use the forks in this use case, right? Another use case, again, would be working on an open source project, and 2 people want to add a feature to this open source project, but they don't have commit access. And in this case, you would use something similar. So locally, I would go and clone my project. And the name of the branch in this case, or fork, is feature. So then I would move into the feature repository, and I do some changes and commits. So now eventually I want to, after I'm done developing the feature, I want to get it back into the main repository. So I can do this with the pull or push commands. But before I do that, I want to see what has actually changed. If I didn't do the changes, if Don did the changes, then I want to know what he has actually changed. And to see that, you can use hgincoming and point it at a repository. And this will list all the changes that happened in the repository since the branch took off. And if you want to see all the diffs, you can also provide an extra command for patch, and it will show you all the diffs in the files that have been changed. So after I'm satisfied and I know what's going to change, I can then finally pull the changes over into my repository like we did earlier. So I'm just going to use hgpull and point it at the other repository, and it will pull the changes across. Again, the history of those changes is now in my local repository, but the changes are not visible in my working directory just yet. I still have to do the merge first. And that's the last command that I'm going to use for this use case, hgmerge, which will allow me to merge the changes. And afterwards, when I'm satisfied, I have a new change that's created, I now have to commit the changes in my repository. So now the changes are merged back together, and I created the feature, I moved the feature into the main branch. This is how it looks like on Bitbucket. The dots are a little bit small on the side, so I'm going to make them a little bit bigger. You can see at the bottom, this is where we started off. We created the first change set, we added a file, and then we branched off. We still made some changes for bug fixes on the main branch in yellow there, but then we committed the feature at the top left. And eventually we came back and merged back with the main branch from the feature branch. You can see there are like a few annotations here. With green, you can see this is the default branch, and you can see at the top right, I'm not sure if you see that at all, there's a little merge icon at the bottom right of the commit message. And unlike all the other ones, you can also see that this change set now has 2 parents instead of 1. So it knows about not only the change set from the feature branch, but also the change set from the main branch. So another use case is collaborative development. If I want to work with a team on a feature and I do have access, I develop internally on a product, for example, Confluence, and I want to develop a rich text editor, and I don't want to use Subversion because those guys are going to have a hard time merging that stuff back in a few months. You want to use Mercurial branches in this case. So in this case, again, I work a lot with Don, once again. We created a feature branch, and I want to work with Don on this one feature. And like before, this time I'm not going to use the clone. I use the branch functionality that I presented earlier, and I call hgbranch feature, which simply creates the feature branch. And from there, I can go and commit my changes and do some stuff and commit it back into the repository. Now, I want to share those changes with Don. So what Don is going to do, Don is getting the repository and updates to the feature branch as well with hgupdate, which will update his working directory to the feature branch. So now every interaction he does is on the feature branch. He can write some code. He programs. He's a pretty good programmer. He's not bad. And he commits his changes in the end and writes a nice commit message as well. Greetings to Jens. And now we have those 2 changes in the branch, right? But eventually, again, we want to merge them back with the main repository after we finish the rich text editor in Confluence. After quite some time, we want to merge them back. And we use the update command once again to update to the default branch in this case. And then we decide to merge the changes back from the feature branch to the default branch using hgmerge and the name of the feature branch. Remember, feature is this convenient name that Mercurial provides for you in order to switch between branches in this case. And after we did the merge, and merged with the feature branch, we simply commit the change set, and now it's in our repository. So again, named branches, they always stay in the history. Remember, they always add this metadata tag. So always, when you look back at the change set, you can always figure out what was this change set for, what was the branch it came from. And this is what this looks like. Again, because it's another type of branching, it looks very similar to what we had before. We created the branch at the bottom yellow point there, the big one, at the default branch. And then we made changes and created a feature there in the green dots. And now you can see the last change set on the feature branch, which is the green one, also has a marker there saying feature. So the Bitbucket guys decided they didn't want to clutter all the changes, which they could do, and display the metadata for all the changes of the branch. But instead, they decided to keep the feature tag at the last change set here. So this is an indicator that this is the feature branch before it came back together and merged. And at the top, again, we merged just like we did before with forks. We merged the feature branch with the default branch. And you can see, again, the 2 change sets now, which are the parent to the commit 7, which is 4 and 6 in this case. So after we worked on a few features, eventually it's time to release the product or release a plugin. In your case, you might work with other people and either use forks or branches if you guys work together in one company. But eventually you want to create a tag and release the plugin to the public. And that's very similar to Subversion, I guess. It's very easy to do something like this. In this case, you simply call hg-tag and you specify the revision number which you deem ready for public. And then you give it a version. That's all you have to do in order to create a tag in Subversion. In Mercurial. And in order to see all the tags, you can call hg-tags, and it will list all the tags that are available in your repository. And to update, again, because Mercurial has now this nice tags and a list of tags, in order to update to a tag revision, and maybe because there's a bug, you need to update to the revision, fix the bug, and eventually merge it back with the main branch. You can simply call hg-update version 0.1, fix the bug, and start working on that branch. So that's the way you create I guess, like a stable or bug fix branch in Mercurial. And to look at, after we did the point 1, we have this convenient tags dropdown at the top in Bitbucket, which simply shows you all the tags that are available. And the same is true for branches actually next to it, which I didn't show in the screenshot. So what did we cover? We covered the differences between Mercurial and Subversion in this talk. And hopefully, I managed to explain the basic concepts of Mercurial to you today. The architecture, and especially the branches and different types of branching and when to use those branches. And in the last, number 3 point, I showed you a few use cases. So hopefully when you go home, you know what you can do with Mercurial and how it enables you to work differently with a distributed version control system over Subversion. If you want to try it out, I encourage you to create an account on Bitbucket. Again, it's free. Just create an account, maybe clone an existing repository, play with it, create your own repository, commit some changes, and just see how magically the merging works. It's really much better than in Subversion. You won't have as many conflicts. So go to bitbucket.org, create your repository, and play with it. If you want to learn more about Mercurial, you can look at one of those references that were really helpful for me to learn about Mercurial and create this presentation and to understand branching and merging and why it's really easier. Because it took me personally a long time to understand what actually makes it easy in Mercurial or other distributed version control systems to merge. Thank you very much. Do you have any questions?
Okay.